Alright, in this video we're looking at linear equations. We'll solve them, we'll solve applied linear problems, and we'll also look at finding zeros of linear equations or linear functions. When you're solving any kind of an equation, as you've seen before, there's different steps or different properties that apply that'll help you solve. In every one of these cases you're looking for x. X is equal to something. Here, this is a linear one. We'll see on the next page some tips for that. This one here, it's a quadratic function to try and factor that. This one here, you try and factor it too. There's synthetic division might help do that. Here you take the arc sine. Here you change form. But there's a different step or property or law that governs how you can get so you have x by itself. With linear equations, here's just a few general tips to solve them. Generally, you want to remove brackets first, then collect like terms using something called the addition-subtraction principle, then use multiplication or division principle to isolate the x. And always at the end, it's a good idea to check your answer. Let's start with this first one here. So they say to remove brackets, and so there's a property that governs that. And to do that, I'm going to use the distributive property. So I'm going to multiply, because that's the operation right there. I'm going to multiply everything inside the brackets by 2. So it'll be 2 times x is 2x. 2 times 2 is a positive 4. This next one doesn't have a number out front, but it does have a sign. And so I need to apply that sign to both. It's a distributive property just like we did in the first one. This one I lovingly call the dirty, rotten, filthy, stinking negative, because it's a negative outside a bracket. That's where many students sort of mess up. So this one will be a minus 3x. A lot of students just put a plus 1 here, but you have to apply that negative to both things, so this would be a minus 1 is equal to 7. Collecting like terms, 2x minus 3x is a negative 1x, or just a negative x. 4 take away 1 is a positive 3 is equal to 7. Life is good so far. Now let's subtract 3 on both sides. So I get negative x is equal to a positive 4. Then I'll use the division property, divide both sides by a negative 1. And so in the end I get x is equal to a negative 4. Hopefully I've done all that correctly. It looks good. But I can check to see whether I've done it correctly or not simply by checking my answer. So I'm going to take this original question, and wherever there's an x, I'm going to put in what I think x should be. Minus 3 times negative 4 plus 1. I'm hoping that gives me 7. Okay, in brackets, negative 4 plus 2 is a negative 2 times 2 minus 3 times negative 4 is negative 12 plus 1. Hoping. 2 times minus 2 is a minus 4. Minus 12 plus 1 is a negative 11. Equals 7, I'm hoping. A negative of a negative, that's a distributive property, so it'll be a positive 11. So negative 4 plus 11 indeed gives us 7, therefore my answer was correct. It's always a good feeling when you do a check that it checks out correctly, so you know that what the work that you did was correct. Why don't you try this question? Try it and check it. Press pause and then press play when you're done. Okay, distributive property, 3x plus 3 equals 5. Distributive property, so it's minus 2 times 3x is minus 6x. Minus 2 times a positive 4 is a minus 8. Okay, collecting like terms, I'm going to bring all the x's over to this side. So this is on the right side of the equal sign. So if I bring it to the left, it'll become positive. And then over here already I have a 5, I take away 8. If I bring this 3 over, it becomes a negative 3. So I'll have 9x is equal to 5 take away is negative 3. Negative 3 minus 3, I think, is a negative 6. Dividing both sides by 9, you get negative 6 ninths, or negative 2 thirds. So now let's check, and maybe you can try this on your calculator. So 3 times -2/3 plus 1. Is that equal to 5, take away 2, times 3 times -2/3 plus 4. Okay, -2/3 plus 1 is a positive 1/3. Oh, and times 3, that just gives me 1. Nice. So I have 5 take away. Let's do this stuff in here. 3 times -2/3. Oh, the 3's cancel, so that'd be -2. So -2 times -2 plus 4. -2 plus 4 is 2. So it'd be -2 times 2. And 2 times 2 is 4, so it'd be -4. 5 take away 4 is 1. Checks out. You could, like I said, just on your calculator right at that point there, plug all that in, and I guess plug it into this side, see if it equals to 1. Plug it into this side, see if it is equal to 1. Just to minimize some mistakes. Okay, so that's linear equations. Now let's turn our attention to making a linear equation out of some words. The textbook, I like how they've outlined just some loose steps that you can use to solve something. They first say to familiarize yourself with the problem. Okay, so we're dealing with word problems, so we'll be dealing with cyclists and banks and posters, whatever. We'll be dealing with lots of things. First step is to familiarize yourself with the question. So as you're reading it, draw a picture of whatever it is, and start maybe labeling some things on the picture. Put things into variables, and so you might want to put a length and a width on something. Put things into variables, and then look at relationships. I guess part of that put into variables is look at relationships, or what kind of properties or laws govern that shape. So this shape here, it's a rectangle, so I could figure out the area of a rectangle. I could figure out the perimeter of a rectangle. If I had a dotted line there, I could do some Pythagoras to help me find some kind of side on that triangle. But all of those properties or laws might be things that you need to use. You may not use all of them, but you might use some of them. So get your concept, your property law, and use your variables, and then do the math. So you'll come up with some kind of an equation, do the math, check to make sure your answer makes sense, and then finally state your answer. So try different things. On exams, I always give points for trying something. So if you just see a worded question and you think, I can't do this, and you leave it blank, you're going to get 0. But if you try something, even if you're trying to draw a picture or trying to make sense of the relationships that they are presenting in the question, that's the important thing. With these, I think I have 3 examples here. With the 3 examples, as I'm going through them, if you wanted to pause each one and just try it on your own, and just see if you can come up with some relationships, and then press play and see if what you're doing mirrors what I'm doing. Okay, so the first question I have is the width of a poster. So I see a poster, it's a rectangle, and so there is a length and a width. They call it a height. It is a height, but just to stick with our normal area lingo or perimeter lingo, let's use length for it instead of height. Okay, so they say the perimeter. As soon as they use the word perimeter, I'm thinking this. Perimeter of a rectangle, 2 lengths plus 2 widths. Okay, so they say the perimeter is 100. So the whole distance around this thing is 100 meters. Oh, that's a big poster. And I would put that right in there where the P is. So 100 is equal to 2L plus 2W. Now up here it also says the width is 2/3 of its height. So the width is means equals, so the width is 2/3, and of typically is multiply. So width is equal to 2/3 times by the length. Okay, so if I'm wanting to find these dimensions, what I can do is I can take this value here and plug it in wherever I see a W in this equation down here. So, let me just draw a line here. That 100 is bothering me. Okay, so I have 100 is equal to 2L plus 2, and then instead of W, I'm writing 2/3 L. So 2/3 times L. Now I have an equation. This equation here has two variables in it, L and W. But this equation, now I've got one that just has one variable. Linear equation I should be able to solve. Okay, so 100 is equal to 2L plus, this would be 4/3 L. Yeah, that sounds about right. Yeah, because if I multiply fractions, it'd be 4/3. Okay, now if I add those together, 2L plus 4L, I think is, let's make this one thirds too, so 6/3. You could add that on your calculator too. So 6/3 plus 4/3 is 10/3. So 10/3 L is equal to 100. And now to solve, I can multiply both sides by 3. And so I'll have 300 is equal to 10L. And then I'll divide both sides by 10. And so 300 divided by 10 is 30. So the length must be 30. Now I can solve for the width. I know the width is 2/3 times the length. So if I know the length is 30, then I can figure that out. So 2/3 of 30, I think, is 20. Okay, so I've done the math. Now I probably should check my answer. And I can probably check it fairly easily just by plugging some stuff in here. So this I'm saying is 30. No. My length is 30. So this is 30. And my width is 20. Okay, now I add them up and see, hopefully I'm getting up to 100. 30 and 30 is 60, 80, 100 worked out. Therefore, I would say the width is 20 and the length is 30. Okay, let's try another one. Salesperson has a base salary of $2,000 on all sales they're responsible for. They'll get an extra 6% commission. Nice. If their paycheck for the month is $27.90, how much did they sell that month? Okay, so let's see how much they get paid here. So they get paid $2,790, and that's made up of a base salary plus their commission. Okay, now their base salary is this $2,000, so I can put that right there. Plus their commission, they receive 6%, so change that to a decimal, multiplied by however much they sell. Let's use an S for sales, is equal to $27.90. Now I've got a linear equation. So to solve it, I want to isolate S, so I'm going to subtract 2,000 on each side. So I'll get 790 is equal to 0.06 times S. And now I'll divide both sides by 0.06. Okay, calculator. Hopefully this will work. Okay, 790 divided by 0.06. Yeah, good. 13,167, call it. 13,167. So S is $13,167. So they must have sold that much stuff of goods. They got 6% of that, and that gave them the $790. Add that to their base salary, and that'll give them the whole amount. Okay, another one. Try this one and then see how you do. Press pause and then play. Okay, anytime I have a distance, rate, time question, I have to put it in a table like this. It just seems to help me make sense of things. So let's figure out the distance, rate, and time for the cyclist. Cyclist leaves Lethbridge traveling 40 kilometers an hour. So that's his rate of speed. So he's going 40. A car leaves an hour later. And they say, when will the car catch up and how far will it have gone? So I don't really know how long it took that cyclist or before the car caught it, but I do know the car left an hour later. So an hour later, so their time would be t minus 1. Now the distance is another thing we don't know. So we're not sure when that car is going to catch up. So let's put a d here. And for the car would be the same distance, right? Because it's going to catch up to it, so it would have traveled the same distance. It's just that it's taking 1 hour less. And the rate of speed of the car is 100. So here I've got a relationship where I have a cyclist and the car, and they each have two variables that I don't know. But what I can do is I can do just like I did in the last question, solve one of the equations for a variable and then plug it into the other one. Okay, so one of the formulas that you can use, and let's do the cyclist first, is distance is equal to rate times time. So for the cyclist, d is equal to, sorry about the capital, non-capital. Anyway, d is equal to 40 times t. Okay, let's do the car. So the car would be d is equal to 100 times t minus 1. Now I've got two equations where they're both actually solved for d, and they work just real well. So you can say at this point that the distance of the cyclist must equal the distance that the car went. So it follows then that the distance the cyclist went is this. So 40 times t is equal to this, 100 times t minus 1. Okay, distributive property here. So 100t is minus 100 is equal to 40t. And then I guess I'll subtract 40t from both sides. So I'll get 60t on this side. And then I'll add 100 to both sides. So I'll get the time is, I'll divide by 60 here. Let me go down a bit. So I'll get the time is equal to 100 divided by 60. And so the time is equal to, I think that's 5/3. And for time, if you divide that, that's like 1.67 hours. So that's how long it'll take before the car catches up to the biker. So from when the biker starts, he's going to bike for about an hour and 40 minutes, and then the car will catch up to it. Now the other question says, how far will the cyclist have gone? So then I can use either this formula or this formula to figure that out. Let's use this one because it's a little simpler. So to figure out the distance, it'll be distance is equal to 40 times t, or distance is equal to 40 times by the time is 5/3. I quite like using an exact number as opposed to an approximation. Okay, so this will be 200/3, and I think that turns out to 66.7 kilometers. I think it's about that. Okay, so the biker would have gone pretty tough to go 66 kilometers traveling 40 kilometers an hour. You have to be fairly fit and a wind behind you or be a professional. I like that question. So now let's turn our attention to looking at the last concept for the day, and that's zeros. And a zero for a function or for a relation is the value of x when y or f of x is equal to 0. And we can do that with these linear relations and linear functions down here. But this concept of 0 is if I'm looking at a graph, here's x and here's y. So if my y value is 0, that happens anywhere along this x-axis. And so really what you're finding when you find a 0 of a function is you're finding that point on the x-axis where the graph crosses there. So it might cross at that point. And we'll do that with these and just see how they look. So to find a 0 in a relation or a linear function, you substitute a 0 everywhere you see a y or an f of x. So here I'd put a 0 in for y, and now what I'm solving for is for a 0. To solve this, I'll subtract 5 from both sides, so I'll have minus 5 is equal to 3x. Then I'll divide 3 on both sides, and I'll get negative 5 thirds. So that tells me that the x-intercept for that graph is at negative 5 thirds. If I were graphing it at negative 5 thirds, here's negative 1, negative 2, and negative 5 thirds would be right about in here somewhere. So that's where that graph crosses the y-axis. And actually the graph is going to look something like that. If we do it with a linear function, the same thing. I put a 0 in for f of x, and I would solve it just the same as I did there. Why don't you try figuring out the 0 of this function? Press pause, then press play. Okay, so to find the 0, you put a 0 in for f of x. In this case, I'm going to, because I want my x's to be positive, they don't have to be, but I like to make them that way. I'll move the 2x to the other side, so I'll get 2x is equal to negative 8, and then I'll divide both sides by 2, so I get x is equal to negative 4. So the 0 of the function is negative 4. This graph would cross the x-axis right there. And the graph probably looks something like that. So in this video, we've looked at linear equations, how to solve them using the properties for linear equations. We also looked at 3 worded problems and how you could solve those. And finally, we looked at determining the zeros of linear functions or linear relations.